Okay, so here is your review for your Chapter 1 test. Number 1, how many planes can be drawn through any 3 non-collinear points? And the answer to this is 1, exactly 1, okay? Because the best way to think of it is imagine the surface of your desk, and if you were to draw 3 points on that desk, on that flat surface, the only plane that would pass through those 3 points is your desk surface. There would be no other plane that would pass through those exact 3 points. Number 2, true or false? D is collinear with A and B. Remember that the word collinear means that they lie on the same line. So D is here, A and B are here. Okay, so A and B are collinear with each other, but all 3 points are not on the same line. So you could have A and D on the same line, or you can have D and B on the same line, but not all 3. So that would have to be false. Number 3, name the intersection of the plane P and the plane that contains points A, C, and D. So A, C, and D, talking about this plane, or actually the plane that passes through this front side of this triangular pyramid, and the place where it intersects with this plane, plane P. And the intersection of 2 planes will always be a line, so the line where they intersect is right there. So the intersection would be line AC, like this. On number 4, find the length of RS. So segment RS, we're measuring in inches. We're looking at our increments here. So if I count from here over to there, I would have 16 marks. So we're measuring in 16ths. So our answer is going to be 1, and then it's past 1, how far? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 16ths. For number 5, we want to find the distance between points P and Q. So we need to use the distance formula. So the distance formula is the square root of x2 minus x1 quantity squared plus, okay, let me rewrite that. Try this again. The square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. So we have our 2 points, so we would label one of our points x1, y1, and then the other one x2, y2. And then just plug those numbers into what we have here. The main thing is we're going to subtract our x's and we're going to subtract our y's, and it does not matter which order we subtract them in. So I could take 8 minus negative 4, or I can take negative 4 minus 8. So I'm just going to stick with the way that I have this set up here, and I'm going to take 8 minus negative 4. And y2 minus y1 would be negative 1 minus 6. And I apologize for all the noise. I'm at the school right now, and I've got all the fans on, and it sounds like they just started mowing outside. So I apologize for that, but we'll do our best. So from here, we want to take 8 minus negative 4, or 8 plus 4, which is 12. Negative 1 minus 6, that would be negative 7. If you type it in on your calculator, make sure that you put it in parentheses, because when you square it, you need to get a positive. So from there, 12 squared is 144. Negative 7 squared is 49. So add those up, and we have 193. So we can express our answer as the square root of 193, or with a calculator to the nearest tenth, that would be 13.9. 13.9. On number 6, find the length of segment PQ. So we want to find the length of this segment. We know that this is 10.8. We know that the whole thing is 29.2. So if we subtract this part from the whole, we should get this part. So my work would just be to take 29.2 minus 10.8, which is 18.4 centimeters. Number 7, find the value of y if b is between a and c, ab is 3y, bc is 5y, and ac is 56. So always make a diagram, make sure that everything is in the right spot before you start setting up an equation. So we have b in between a and c. So this is 3y, bc is 5y, and our entire length is 56. Now, from the idea of betweenness or the segment addition postulate, we would say that the two parts added together is equal to the whole. So combine your like terms, you get 8y. Divide both sides by 8, and y is equal to 7. Always go back to the problem, make sure that we solve for the right thing. Here it says find the value of y. Sometimes it might ask you to find the length of AB, and you'd have to substitute that back in, but in this case, our answer is just 7. Okay, on number 8, we have another distance formula problem. Here's our distance formula. Label one of your points x1, y1, the other x2, y2, and start plugging things in. So we want to take x2 minus x1 squared plus y2 minus y1 squared. Simplify what you have. So 7 minus 3 gives us 4 squared, and 7 minus 10 gives us negative 3 squared. So in my next step, I square those. 4 squared is 16. Negative 3 squared is 9. So we have a sum of 25. And this would be a perfect square. So we want to take the square root of it because it is exactly 5. So if you don't get an exact answer, you can leave your answer as just the square root, but in this case, it's a perfect square, so the answer is 5. All right, for number 9, find the coordinates of the midpoint of segment LB. If L is 11, 8, B is negative 4, 3. Here's our midpoint formula. Label one of your points, x1, y1, and the other x2, y2. You can do it this way or vice versa. And then just substitute in to this formula. So basically we are finding the average of the x coordinates and the average of the y coordinates. So we want to take 11 plus negative 4 and divide by 2, and 8 plus 3 and divide by 2. So 11 and negative 4 will give me 7. 8 and 3, I get 11. I can write that as a decimal. Whoops. So 3.5 comma 5.5. On number 10, the midpoint of a line segment. Let's try that again. Mowing outside. All right. So the midpoint of a line segment AB is 2, 3. Point A coordinates are -11, -1. Point B coordinates are x, 4. Find the value of x. So here's my segment. Here are my coordinates for A, my coordinates for B, and my coordinates for the midpoint. So I need to set up an equation with the x in it and then solve for x. So from my midpoint formula, I know that the average of my x coordinates, or in this case, -11 plus x, because I don't know what that x coordinate is, so divided by 2, has to equal the x coordinate of the midpoint, which is 2. So we just solve this equation. Multiply both sides by 2. That cancels. We get 4 on the right. So add 11, and x equals 15. Number 11, what type of angle is angle AEF? AEF. Okay, so clearly we're past the 90 mark, which means we are in the obtuse range. Number 12, find the measure of GED if ED bisects GEF. So what we want to do here is, if this is the angle bisector, then it's going to split the angle into two congruent angles. So those two angles are congruent. If they're congruent, we set their expressions equal to each other and solve for x. So subtract 5x from both sides. Add 18 to both sides. And x is equal to 15. Take that back to the original problem. It says find the measure of GED. So GED is 6x minus 18. And 6 times 15 minus 18, we get 72 degrees. Exercises 13 through 17, use the figure at the right. Find the measure of FBD if FBD and DBE are complementary, which means they add up to 90 degrees. And the measure of FBD is twice the measure of DBE. So if we call the measure of DBE x, then the measure of FBD is twice that, or 2 times that, so 2x. If they're complementary, then x and 2x have to add up to 90. So we solve this equation. And x is equal to 30. Take that back to the original problem. So we want to find FBD, which was 2x. So the measure of angle FBD is 2 times x, 2 times 30, or 60 degrees. Okay, on number 14, which pair of angles are supplementary? Supplementary angles add up to 180 degrees. So we can have non-adjacent supplementary, we can have adjacent supplementary. Adjacent supplementary angles form linear pairs. So if I go to any straight line here, take for example this line, and I just need 2 angles along this straight line. So I could use this ray to do that. So I have, I have this angle, and I have this angle right there. So So if I take those two measures, add them together, I would get this straight line. I would get 180 degrees. So an example here would be angle ABE and angle EBD. Number 15, which angle is vertical to angle ABC? So vertical angles are formed by two straight lines, two intersecting straight lines, and they're the angles that are non-adjacent or not next to each other, or they're the ones that are across from each other. So if we have ABC, we're talking about this angle, its vertical angle would be right here, which is what? EBD or DBE. Number 16, if the measure of angle CBF is 5x plus 15, find the value of x so that CB is perpendicular to segment BF. So if these are perpendicular, perpendicular means that they'll intersect to form right angles. So this angle we now know has to be 90. So we want to find the value of x such that 5x plus 15 equals 90. And once again, I apologize for the mowing outside. So 5x plus 15, subtract 15 from both sides. We have 5x is equal to 75. And we divide by 5. So x would have to equal 15. Number 17, find the measure of angle ABC. If ABC is 4x plus 9 and EBD is 7x minus 9. So ABC, this angle, and EBD, this angle. So what can we say about those? We can say that those two angles are congruent. Why can we say that they're congruent? Because they're vertical angles. Two intersecting lines, and they're non-adjacent. So if they're vertical angles, they're congruent, so we set them equal. So 4x plus 9 will need to equal 7x minus 9. So subtract 4x from both sides. Add 9 to both sides. And divide both sides by 3. So we get x is equal to 6. Take that back to the original problem, which says find the measure of ABC. So ABC is 4x plus 9. So we need to substitute our x in. And so we get 33 degrees. Number 18 refers to the figure. Name two acute vertical angles. So we have vertical angles there and there, and vertical angles there and there. We need to decide which pair are acute. So acute is less than 90. So we have 39 degrees, 39 degrees. There we go. So that would be angle QRU and angle SRT. Acute vertical. Number 19, angles SRQ and QRT form a linear pair at vertex point R. Which 3 points, Q, R, S, or T, are collinear, are on the same line? So you have to make a diagram here fitting this information. So we have SRQ in QRT form a linear pair at vertex point R. So we have our straight line, two adjacent angles along a straight line are a linear pair, vertex point R, which 3 points Q, R, S, or T are on the same line. So we can see very clearly that that would be S, R, and T. Number 20, what is the value of X and the length of AB if B is between A and C? If AB equals 4X plus 5, AC equals 59, and BC equals 10X minus 2. So let's make a diagram. And B is between A and C, and AB is 4X plus 5, and AC is 59, and BC is 10X minus 2. So the segment addition postulate, since B is between A and C, then AB plus BC must equal AC. So our equation would be what we have here. So the two parts added together equals the whole. So we combine our like terms. We subtract 3 from both sides. And we divide by 14. So our X is equal to 4. That's part of it. So we have X. We also want to find the length of AB. So we want to substitute it in here. So that would be 4 times 4 plus 5. The length of AB is 21. For the bonus, find the measure of A if A is complementary to B. So A plus B equals 90. B is supplementary to C, so B plus C equals 180. And the measure of B is 15x minus 2, and the measure of C is 25x plus 22. So we can substitute those in to this equation. Plus C, which is 25x plus 22. So combine your like terms. Subtract 20 from both sides. Divide both sides by 40. And X is equal to 4. Let's go back to the problem, see what it's asking for. Find the measure of A if A is complementary to B. So now we have to take it back to this equation right here. So we need to know what B is. So B is 15x minus 2. So if B is 58, plug that in up here. then the measure of angle A is 32 degrees. And that's it.